So in some ways it obviously depends what you mean by intelligence, but and also there's the risk of anthropomorphizing, because of the current way that we think about the world. So does matter think? Well, matter can make decisions. I mean, so the droplets I work with, you put them in a dish and you add some chemicals, and those droplets can make their way towards those chemicals. It's a very simple physical process. It's now supposed to be a decision if it can make a decision between two different chemicals, but we've not demonstrated that there's anything more sophisticated than a physical reflex. Although you could answer, and so some determinists who for example, neo-Darwinists essentially say that everything you do is in your genetic program, so there is no free will, so that in some ways those people believe we don't make any decisions anyway. So whether a droplet is making a decision about whether to move or not also becomes philosophically quite problematic.
Maybe a better way. Protocells that you're talking about.
Yeah, that's right. Yes, these are.
Just quickly, could you describe what they do for people that don't understand?
Yeah. So protocells. I mean, so the definition of protocells is controversial. Okay. So eminent scientists from Los Alamos have coined a term for protocells, which is an artificial cell. In other words, one that has a container, metabolism, and information, and it can self-propagate. I don't use protocell in that context. For me, proto means like before or primary, cell, obviously a cell. So I think of them as being the things that happen before we have a proper biological cell. And so these smart droplets, they're not alive because they don't possess any DNA. They haven't really got a centralized program that we tend to associate with biology or life. And yet they have this general natural computing ability that allows them to work in very lifelike ways. So they can move around their environment, they can sense it, they can work with other little droplets or protocells, and they can even make substances. So you can actually get very complex interactions out of very simple things that are literally just made of oil, water and alkali. So you've really got about 3 or 4 different substances involved. So they're incredibly simple. They also don't occur naturally, although it is said, and the origins of life theories propose that these kinds of agents were around in the black ventas in the deep sea, in the abyss, and the intense heat complexifies molecules. And so it produces the fats, and of course they also have alkali. Mm-hmm. So the fat and the alkali makes a kind of soap, but this is essentially the molecular relationship that's driving all this. Essentially, they don't need external energy like a machine does. They actually have an internal energy source, which is their chemistry.
Were these precursors to single-cell organisms, or?
I think scientifically we would never say that, but they are essentially a model system that starts showing us just how dynamic and complex chemical interactions can be.
You're always specific to say that this does not have DNA and this is not biology. Is that because that's not your field? You want to just focus on something that's not quote-unquote living? Or is that something you're open-minded to, if it can be a solution to, say, saving Venice?
Well, I think I don't think
that's a black hole question.
Yeah. Well, I don't think we actually need it to be biological. I mean, so biology has we have a very particular and culturally and scientifically defined idea of what life is. I mean, so the ones that they're using at Los Alamos, for example, is based on this chemiton model, which is invented by a Hungarian called Tibor Ganti. And essentially, he said, you need a metabolism, you need a container, and you need some information for it to be capable of being a life. Mm-hmm. And biology is actually much more complex than that. I mean, that chemiton model is really like the simplest possible set of rules that you could have to produce a living thing. And biology is way, way, way more complex than that. It's got DNA, it's got protein factories, it's got regulatory mechanisms, it can reproduce. So for something to be biological, I mean, there are obviously advantages. So things like being able to make more of itself is something that biology does well. But in terms of a technology, do you really need something that's that complex? Do you actually really want something that's going to self-replicate? Or do you actually want
mutate?
Or mutate? Yeah. Or do you want actually something that's just simple enough for you to be able to guide its movement just by feeding it? By taking away some resources or just adding more of the agents. So in some ways that that these protocells exist between what we might think of as being synthetic biology, the design and engineering of things that are already alive, and that we can shape through technology, and actually exist between, you know, something like setting concrete. Setting concrete is fascinating. It's like a chemical garden, you know, until it sets and becomes a geometric blob. It's full of wriggling tubes that crawl over each other and knit together.
Oh,
It's a fascinating...
Well, concrete itself.
Concrete is
Oh, yeah,
fascinating
yeah.
until it sets. The moment it sets, it just turns into these, you know, densely packed crystals. But until that point, it's you know, it's squirming around like worms. So essentially, these protocells exist somewhere in between, you know, squirming tubes and a biological system, and much more towards the squirming tubes than the biology.
Wow. You know, you were